Game Theory Fundamentals, Episode 1. Prisoner's Dilemma. For our first episode, we'll learn about what game theory is, and how it can help us understand and predict human behavior. What is the prisoner's dilemma, and how it illustrates the tension between individual and collective rationality? How the prisoner's dilemma can be applied to climate change, and what are some possible solutions? First pioneered by mathematician John von Neumann and economist Oskar Morgenstern in 1944, game theory is the study of mathematical models of strategic interactions among rational agents. Simply said, it's a way of studying how people or groups make decisions when they know their choices affect each other. Here are basic rules of game theory. 1. There are multiple players, 2 or more, each with multiple strategies. 2. There needs to be payoffs. 3. There needs to be outcomes. 4. Payoffs and outcomes are predetermined according to the strategies. 5. We assume that players act rationally. 6. We assume that players act according to their personal self-interest. The goal of each player is to choose the strategy that maximizes their payoff, given the strategies of the other players. With following basic definitions. Players are the decision makers in a game, who have different preferences and choices. Strategies are the actions or plans that each player can choose in a game. Outcomes are the results of a game, determined by the choices of strategies made by the players. Payoffs are the rewards or costs that each player receives or incurs in each possible outcome of a game. Payoff matrix is a table that shows the payoffs for each player for every possible combination of strategies in a game. Now, let's start with a classic example, the prisoner's dilemma. Imagine 2 suspects, Alice and Bob, are arrested and interrogated separately by the police. The police have enough evidence to convict them of a minor crime, but they want to get them to confess to a major crime. The police offer each prisoner a deal: if they both cooperate and remain silent, they will each get 1 year in prison. If they both defect and betray each other, they will each get 5 years in prison. If one cooperates and the other defects, the cooperator will get 10 years in prison and the defector will go free. In game theory, it can be represented by the following payoff matrix, where the rows correspond to Alice's strategies and the columns correspond to Bob's strategies. The payoffs are the number of years in prison for each player. The left ones represent Alice's payoffs while the right ones are Bob's. They are negative since they are not favorable for them, so the larger the number, the better for them. Let's identify the elements. Our players are Alice and Bob, or A and B for short. The strategies are cooperate, silent, or defect, confess, which can be written as silent, confess A, silent, confess B, with following payoffs for Alice and Bob. And here are the outcomes. The question is, if you were Alice, what would you do? Is it better to stay silent or confess? To answer this question, we need to think about what each player expects the other player to do, and how that affects their best response. If you are one of the prisoners, you have 2 options: confess or stay silent. You don't know what the other prisoner will do, but you can guess based on their self-interest. If you think they will confess, you should also confess, because then you get 5 years instead of 10. If you think they will stay silent, you should also confess, because then you go free instead of getting 1 year. So, confessing is always better for you, no matter what the other prisoner does. This is called your dominant strategy. The problem is, the other prisoner thinks the same way. So, both of you end up confessing and getting 5 years each. This is the Nash equilibrium, which means that no one can do better by changing their strategy, given what the other player does. However, this is not the best outcome for both of you. If you both stayed silent, you would each get 1 year, which is better than 5 years. This is the Pareto optimal outcome, which means that no one can be made better off without making someone else worse off. We will explore these definitions in more detail in the upcoming videos. The prisoner's dilemma shows that rational players may not cooperate, even if it is in their best interest to do so. This is because they face a conflict between their individual and collective interests. Now let us see how prisoner's dilemma can be applied to a real-life problem, such as in climate change. You can skip this part if you have a good grasp of the climate change challenge. Climate change is a global problem that affects everyone on the planet. It is caused by the accumulation of greenhouse gases in the atmosphere, which trap heat and raise the average temperature of the Earth. This leads to various negative consequences, such as melting ice caps, rising sea levels, extreme weather events, loss of biodiversity, and threats to human health and security. The main source of greenhouse gases is the burning of fossil fuels, such as coal, oil, and gas, which are used for energy production, transportation, and industry. These activities are essential for economic development and human well-being, but they also contribute to the problem of climate change. Therefore, we face a trade-off between our short-term benefits and our long-term costs. This is where the prisoner's dilemma comes in. Suppose you are a country that wants to reduce greenhouse gas emissions to prevent global warming. You know that other countries also want to do the same, but they also want to maintain their economic growth. If you and other countries cooperate and reduce emissions, you will all benefit from a cleaner environment and a more stable climate. If you and other countries defect and increase emissions, you will all suffer from more pollution and more extreme weather. If you reduce emissions and other countries increase emissions, you will bear the cost of environmental protection, while other countries will reap the benefits of economic development. This is a prisoner's dilemma because the best outcome for all countries is to cooperate and reduce emissions, but the best outcome for each country individually is to defect and increase emissions. So, what can we do to solve this dilemma? How can we encourage cooperation among countries to achieve the optimal outcome? Well, there are several possible solutions, such as creating international agreements, imposing sanctions, providing incentives, and raising awareness. So have you ever encountered any situation where you need to use game theory concept? Stay tuned for our next episode, where we'll explore the different types of games, and how game theorists use them to model various situations and scenarios. Trust me, it's a game changer. Don't forget to subscribe, so you're the first to know when that video drops. Till then,